I am surprised at how often people run into trouble with this. What I mean by that is, often it happens when you've got units of measure. And so you've got something that's measured in feet squared, and then they're asked to change it to inches squared. And they think that they're just going to multiply by 12. Because isn't that the conversion for feet to inches?
Yeah.
But because it's area, you got to multiply by 12 squared. And so that's an application of this idea right there. So we actually did some problems. Did you guys work 6 and 7 on your own?
Yeah.
No.
Yeah?
5, 6, and 7. I
You
think.
should definitely do
It's
7.
just
5,
3 and 4.
6, and 7?
No, I did 5.
Yeah, you just left 3 and 4 because they were kind of difficult questions. So
Okay.
we did the rest of them right.
I did
Well,
5.
so on 5, it looks like I've already got the ratio of the perimeters to be 2 to 3. Does everybody get this, that if they're asking for ratio of perimeters, you only need to do the sides and reduce it? Because if you do the perimeters and reduce it, it's gonna be the same thing. Is everybody with me on that?
Yeah.
But areas not so. You want to square them. But this was asking to find the unknown area. So they're wanting this area right here. And so you can set up a proportion. Is it proportion?
Pro.
Yeah, it is pro. Yeah. All right, how am I going to set that up? Most of you already did this, so help me out.
I think I got it wrong.
What do you think?
I did 780 centimeters squared divided by 9 times 4.
I don't trust my
Oh, okay. So I bet that's right. But let's just set up one ratio equal to another ratio.
I had 4/9 is equal to x over 780.
That's exactly what I have, but I didn't trust it.
All right. So 4 to 9. Do you guys see how that's little to big? So when we compare the areas, we want to do little to big. So I like that setup. That looks good. And then to multiply this, you could cross multiply. You could multiply by both denominators, or because x is on top, just multiply by 780. And I'm going to cheat a little bit. I got 346 2/3. And then what's the units?
Centimeters squared.
Centimeters squared. Are you guys okay with that?
Yes.
Yeah, that's what I got.
It's been a little bit, hasn't it?
It's been a hot minute.
Are you guys are okay? So Gary, did you do it wrong?
No, I was
I
looking at
don't-
the wrong question actually.
Oh.
I don't.
Okay.
My calculator did not let me just get that. So.
Did you get a decimal?
Yes, and then my calculator for some reason does not transfer decimals to fractions.
Okay. So do you have your calculator?
I do. Gary had to teach me the 2/3 thing.
So show of hands, how many of you are done with number 6? Okay, so I'm gonna go ahead and just show that and see if you agree. I might have come around and checked you on this one.
Yeah.
Yeah. More fractions, huh?
Scary.
It wasn't working last
It wasn't?
time. No,
Okay.
it wasn't.
That's all right. Maybe it was taking the day off. So you guys good with 6?
Yeah.
Do we need to work out 7 together?
Wait,
No.
hold on, wait. I didn't look
No,
at
we
this.
definitely need to do that. one,
Oh, we do need to?
Yeah.
Oh. Well, so 7, it says rectangle 1 is similar to rectangle 2. In rectangle 1, the length is 20 feet and the perimeter is 64 feet. That's interesting. So let me go ahead and draw that real quick. Rectangle 1, it says that its length is 20 feet but then it says its perimeter is 64 feet. Well, shucks, since this is a rectangle, can't I figure out all the rest of the stuff? I bet I could. I'm gonna wait, because maybe I don't need to. Then it says rectangle 2. The width is 8 yards. Yep, 8 yards. So width. Oh, this was our length, wasn't it, on the other one? So width, I'm gonna have to make the other. Do you guys get that?
Yeah.
Yeah, because I called this one my length on this, so width would have to be this. It's 8 yards. Does that bother anybody?
Yeah.
It kind of bothers me a little bit. It might not be an issue, but can we easily convert that? How many yards in, or how many feet in a yard?
3.
So this is actually 24 feet, isn't it? And it asks us to find the ratio of the area of rectangle 1 to the area of rectangle 2. Well, ladies and gentlemen, I don't know a lot about this rectangle at all. On this rectangle, I can figure out a bunch more stuff, can't I?
Yeah.
Well, if I can't compare 20 feet to 24 feet because they're not in the corresponding positions, are they? So let's spend a little bit of time over here. If this is 20 feet, what else is 20 feet?
Other side, opposite side.
The opposite side on a rectangle. That adds up to 40. What's left over?
24.
24 is left over, but don't we have 2 more sides?
So it's 12.
So aren't these gonna be 12
Yeah.
and 12? Now, what I can do is, do you agree that I can get a ratio for sides? It's gonna be 12, oh, see, find the ratio of the area of rectangle 1. So I'm going 1 to 2. I'm gonna do 12 feet to 24 feet. That reduces to 1/2, doesn't it?
It does.
Now that's the ratio of the sides. What are they wanting?
Area.
Area of the ratios. I mean, the ratio for the areas. There we go. The ratio for the areas. So what do? We square both of them. And what do you get?
1/4.
1/4. How do you guys feel about that?
Pretty good.
Very good?
Yeah.
Yeah?
Uh-huh.
Well, have we done either 3 or 4?
No.
Okay. Let's look at example 3 first. A small flat screen TV is 24 inches wide and 18 inches long. So we know quite a bit about that one, don't we? It says the area of the larger screen is 657 square inches. And they want us to find the width of the larger TV. I'm gonna draw a picture. Small TV, large TV. Have a good day. What do we know on the small TV? 24 by 18, don't we? What do we know on the larger TV? The area is 657 inches squared. And what are we trying to find?
The width of the larger TV.
So did I make this the width? 24 inches wide, yeah. So aren't we trying to find this right here?
Yes.
All right, what is that right there? Well, any ideas?
Try to
I think
find
we should
the
find
area
the
of
area
the
of the smaller TV first.
Oh, you could, and then you could compare area to area, right?
Mhm.
Ah, I gotcha. So the area of the smaller TV is going to be 18 inches by 24 inches, right? What does that multiply together to make?
432.
432 inches squared. And now we can compare areas to areas. So we'll do 432 inches squared over 257 inches squared. Does that reduce?
It's 600.
It's what?
657.
It reduces to 650.
No, it's
No, you said
600.
257.
Oh, I say weird things. Yeah, sorry about that. Does this reduce?
Yeah, 48 over 73.
48 over 73? Okay. I got bad news for you. Whoops. I got bad news for you. This is the area ratio. But what are we trying to find?
The width of that.
A side length. Is
This
this
inside the side ratio, wouldn't it be that square root technically?
It would be this square rooted. Exactly. Are you guys with me on that? Because we're going the other way, the other direction. But the reason I say we're unlucky is because
You don't know the square root too well.
are those perfect squares?
Not really.
They're not. But you know what? Let's not sweat. Let's leave it square root 48 over square root 73.
That would play on the survey.
And let's write a ratio. This is the ratio of the side lengths. What side do we know? We know 24, and that goes with this one, right? So it goes on top. 24 over x. Are you guys cool with that?
Yeah, sure.
And now we can multiply by both denominators or cross multiply. And we'll get something like x square root 48 is equal to 24 square root 73. What's left to do to get x by itself? Divide by square root 48. This is kind of fun. Like not doing anything really. And now we can grab our calculator. And be careful, because depending on what calculator you have, you've got to really tread lightly here. On some calculators, you're probably going to do square root 73 first, then what? Times 24 equals, and then divide by square root 48. Help me out, what do you guys get? If you round to the nearest tenth, it's 29.6. And what would the units be? Inches. Pretty wild, huh? Now, just a heads up, you could get decimals for these, but since I didn't round until the very end, isn't my answer going to be about as accurate as it can be? If you round too soon, it's going to cause trouble. Well, ladies and gentlemen, that's one way to do this problem. Can I show you guys real quick another way that you could do it?
Sure.
Another way that you could do it, and this is actually how I thought to do it first. I said, oh, well, if this is 18 and 24 and these figures are similar, that means this would be 18x times some scale factor. This would be, guess what?
24.
24x, because it's either bigger or smaller, right? Well, we actually know it's bigger. Then what I did was I took 18x and multiplied it by what?
24x. No,
And then I set it equal to what?
the area.
And I solved it. And so it actually, I don't want to scare you guys, but there's a little bit of excitement involved here. So 18 times 24, oh, that's 432, isn't it? Okay, so, and then I did 657 divided by 432, and I got this. And then I had to square root it, because at that point I'm at x squared equals all that stuff. But when I square rooted, I get 1.233 2, and it goes on, doesn't it? So that's my x value. Does that match the answer we got?
No.
It doesn't. But you know why it doesn't? Because we're trying to find this here width. And this here width I had as 24 times x. So, I'll do I should have kept it in my calculator, 1.2332 times 24. And guess what I get? Then I get the same answer. It's another way to do it. Well, let's do one more. Example 4 says the Pentagon in Washington, D.C. is a regular pentagon. Do you guys know what we mean by regular?
Same side length.
Same side lengths and same angle measures. Yep. So draw yourself a pentagon. And it says that each side of the base of it is about 900 feet. And the area is about 1,400,000 square feet. But it says you have a scale model of the Pentagon for which the perimeter of the base is 30 yards. So since it's a scale model, it's probably smaller, right? That makes a little more sense. And it tells us the perimeter is 30 yards. Finally, it's asking us to find the area of the base of the model to the nearest square foot. Well, ladies and gentlemen, are we ready to write a proportion and solve this?
I think so.
Well, if we were, we would need to know either both areas, or we would need to know corresponding lengths. Do we know both areas?
No.
Do we know both corresponding lengths?
No, but we could.
We can figure it out.
We can figure it out. This is 30 yards. Now, is this bothering anybody? The fact that it's 30 yards?
We could switch it to feet and it'll be 90 feet because every yard is 3 feet.
Every yard is 3 feet, so yeah, multiply this by 3 feet per 1 yard. The yards cancel, we're left with 90 feet. I like that. So that's the perimeter that we can deal with. Now we're in the same units, aren't we? Well, any other good ideas?
You could divide by 5 for each side.
Oh, because this is perimeter,
Mm.
and since it's pentagon, these are all the same, so divide by 5. What do you guys get for the measure of one of the sides?
18 feet.
18 feet. Now, can you write a ratio?
Yes.
Because you got same, don't you? You got side lengths here. To make it a little bit easier, I'm gonna do 18 feet over 900 feet. The reason why is I know I'm gonna end up trying to find this area, so I'm gonna put that on top. If that kind of makes sense. Does 18 over 900 reduce? Always reduce them first. Is everybody with me on that? Did you say 1 over 50?
Yeah.
Nice. Nice. The calculator's smart.
Yeah.
Alright. Well, here's the thing, ladies and gentlemen, we're trying to find area. This is a ratio for sides. So what do we do?
You can put the area of the one that we do know corresponding to the side length of it. Hope that makes sense.
Well,
Makes sense
the
enough.
problem with that is you're comparing areas with the side length,
Wait, you
and that'll
gotta,
mess up a ratio.
You could.
should you square them?
So you could just-
Oh, could we just square them? Yeah, totally. We could just square them. What's 1 squared? What's 50 squared?
2,500.
So now, this is the area ratio, isn't it? And we can use the area ratio to set up a proportion. Since we did 18 over 900, reduced it, squared it, we got 1 over 2,500. How am I gonna write the other side of this proportion? X over 1,400,000.
Sounds like it.
And then because we set it up like that, don't I just need to multiply 1,400,000 times 1 over 2,500?
Yes. Shouldn't be too hard.
Does anybody agree?
Yes.
Yeah, 560.
Mhm.
560 is a jolly answer.
Yippee,
560 what?
square feet.
Square feet. What do you guys think?
That's pretty cool.
It's not bad. And you know, probably the most important thing to realize here is that this person has a quite large model. of-
Where does
Yeah.
he keep this?
Yeah, I don't know, but the lesson here is follow your dreams. You know? Don't let anybody say that's too big of a
He
model.
wanted to
No,
work at the
you-
Pentagon, and this
you-
was the closest he got.
This is as close as you got, you know, yeah, follow your dreams. Well, ladies and gentlemen, I want to quiz over this the next time we see each other. Is that tomorrow?
Odds are
Yeah,
down.
I think it is.
That's
Yeah.
totally tomorrow.
How about we don't do
How
that?
about no?
Please.
Yeah,
This is
so-
Thursday.
Thursday sounds like a good idea.
How about,
And,
I agree with that.
you've got the rest of the hour to practice. That's the kicker right there, isn't it? You've got time to practice this and ask questions. You're gonna be ready for a quiz tomorrow.
Technically, I have the rest of the hour to learn it.
Yep, and you can do it. You can do it. 3 through 21 odd, and by the way, number 17, you might wanna make sure to do that one. And then 26 through 28 all. So yeah, have at it, everybody. I'll be around to help you out, and we will quiz tomorrow.